Hello, everybody. My name is Masood Olia, and I'm a professor in School of Engineering at Wentworth University. And I'm here with a problem related to uh, dependent motion. And I've already shown you a problem actually like this with the kinematics part. And I want to kind of remind you about this problem. My goal is to do a kinetics part. In fact, let me just get rid of my video so I don't distract you here. Sorry, guys. So I want to go to actually a YouTube video that I've done prior to this video and remind you about the kinematics work that we have done already on this problem. And I'm going to come back and do the kinetics part, which would be a little bit more interesting. And then at the end, I'm going to show you a simulation problem, a simulation of the same problem. Okay, so what I meant by the kinematics, and I'm going to actually put the link in the when I upload this video. So if you look at the YouTube for this, you guys remember that we did this problem kind of like if we know that the speed of the crate here is, crate E is 4 meters per second upward, what would be velocity of point A on this cable attached to the motor? So we went through the analysis, right? Basically, there were 3 ropes here. I showed them in the black, red, and the blue, and then I find the total length of the rope based on these position vectors that I have here. And then I showed that eventually the equation that we have is relating velocity of A and velocity of the crate E or B. Actually, it doesn't matter. Notice that velocity of B and E are the same. Is going to be that velocity of A plus 8 velocity of B equals 0. That's the equation. So now I want to go one step further. Let me go back to our problem here. So remember, this was the equation that we got. So let's go ahead and say velocity of A plus 8 velocity of B equals 0. So basically velocity of point A is 8 times velocity of B, or I call this E actually. And remember, velocity of B and E are the same, or acceleration of B and E are the same, right? So if you go ahead and take the derivative one more time, right? This is actually the equation that I would like to use eventually in this problem. So it's exactly the same equation in terms of velocity or acceleration. Now, let's say to make this problem more interesting is that I remove this motor here and I put a block here. I call it block A, right? So again, I can use the same coloring that I use here. So I had a, I guess I black here. So this is rope 1. I use red here. This is rope 2. Remember, each cable has its own tension. And I guess I'm going to use green here since I don't have blue. So the black rope tension, I'm going to call T1. The red rope, I'm going to call that tension T2 because they're all different. And the rope in red, in green, I'm going to call it tension 3. Okay? All right. So the goal is to, if mass of A, mass of this guy is 10 kilograms and mass of E is 30 kilograms, mass of B, E and B in a way when we do the simulation are the same thing, is equal to 30 kilograms, then what would be the acceleration of each block? All right. And then, and remember, this is also E here, if you want to call it E. Okay. So A and B and E have the same acceleration or velocity. All right. So what would be the acceleration of A and E, and what would be the tension in each chord, meaning T1, T2, and T3? All right. So let's start our analysis. So so this is the kinetic analysis. We need to draw a free body diagram. So the tension in cable, black cable is T1. So that's the tension T1, right? And then the weight of this guy is 10 times gravity. G being here 9.81 meters per second squared, right? At the end, I'm going to plug in the G. All right, what about block E? Be careful, guys, now. Block E, remember, the tension is T3 here and T3 here. So you have two of these tension here, right? I'm actually just going to use green to be consistent. And then what's the weight of E is 30, mass is 30 kilograms times G. All right, now, remember that these pulley D here and pulley C here, and eventually even pulley B, but I really don't care about pulley B because I know the effect on pulley B is the same as if it's on crate E, as shown here in the free body diagram. But look at the free body diagram of pulley D and pulley C, actually. That's what I want to show you. And remember, the mass of these guys are neglected. In other words, mass of D is 0 and mass of C is 0. All right. So what does that mean? So let me show you. So look at pulley D, guys. There are two segment of the cord T1 attached to it. You see T1 here, right? And then what do we have? We have in red T2 here, right? And then what about pulley C? You see a T2 here and a T2 here, right? And then what about this green cable? That's T3. Remember, we called it T3. So basically, that's all the free body diagrams that we have. But let me actually work on these two pulleys here to show you what's going on. So you see, if you apply the equation of motion F equal ma in the y direction, right? Let's see what happens. So we have 2T1, right? Two of these going up and a T2 going down. So negative T2 equal mass of D times acceleration of D. But remember, mass of D is 0. Therefore, even though pulley D is going up and down and has certain acceleration and speed, but it's in equilibrium because its mass is 0. So therefore, T2 becomes 2T1. All right. Similarly, you could use the same argument that 2T2, if you apply the equation of motion here, minus T3 again, mass of C is 0, so that would be 0. So T3 becomes 2T2. So eventually, you see how T2 is what? T2 is 2T1, so you could replace this by 2T1. So actually, it says T3 is equal to 4T1, and that would be important relation that we have to use. Okay, so here we go. Now I'm going to apply the equation of motion to block A, and then eventually to block E. So remember, F equal ma in the y direction. We'll pick this to be positive direction, right? So we have T1 minus 10G equal mass, which is 10 kilograms times acceleration of A. Similarly for B, what do we have? We have 2T3 minus 30G equal 30 kilograms times acceleration of E. All right. So now look, guys, I have T3 equal to what? 4T1. So I can change this to what? 4T1 minus 30G equal 30 acceleration of E. So this equation becomes 8T1 minus 30G equal 30 acceleration of E. Now, I also have a relation between acceleration of A and E, right? In other words, you can say acceleration of A is negative 8 of acceleration of E, right? So look, I can now replace this acceleration of A by what? Negative 8 acceleration of E. So you see how I'm trying to reduce this to two equations, two unknowns. So I'll put the two equations here. So let's look at this equation. T1 minus 10G equal what? Minus AD acceleration of E, right? Minus 8 times 10, right? And look at this equation, 8T1 minus 30G equal 30 acceleration of E. Look, two equations, two unknowns. Solve this system of equations any way you like. It makes sense to multiply maybe the first equation by -8 so that we can get rid of the T1 using elimination method. So if I multiply out, this becomes positive 80 and this becomes positive 640. So now add, right, the two equations. So what do we have? You have minus 8T1 plus 8T1, so T1 is eliminated. We have plus 80G, right, became positive, right, minus 30G equal what? 670, 640 plus 30, 670 acceleration of E. So 50G, remember G is 9.81, 670 acceleration of E. Therefore, acceleration of E becomes 50. Now it's time to put 9.81 in there, divide by 670. Let me see if I have acceleration of E here for you. I have done this calculation earlier. I guess it becomes a relatively small number, a positive 0.732 meters per second square. So this basically means E is going to move in the positive direction. So it's going to move up, accelerate up. And then remember, acceleration of A was -8 acceleration of E. So -8 of what? 0.732. So acceleration of A becomes negative, let's see, what do I have here? Negative 5.856. Negative means what? A is going to move down. So this, if I had a crate here of that mass, it's going to move down. And then guys, look, I can go ahead and find T1. Remember T1, you can use this equation if you want. T1 is equal to 10G plus 10 acceleration of A. So if I put acceleration of A here and G is 9.81, T1, let me see, what did I calculate? It's 39.54 newtons. Remember, T2 is twice T1, so T2 becomes twice that. So twice 39.54 becomes 79.08. And then remember, T3 was twice T2, right? So twice 79 is about 158, almost 160.16 newtons. All right, guys. So what I want to show you now, let me get back so I can talk to you guys. So what I want to show you is now a simulation of this. So if I could go back here and see if I could share my screen, because I have a software called working model, which I can simulate these things. So let's see if I could show you the my screen here. So let's say share screen with you. Okay. Let me see if I could do that here, guys. Just give me a second. I don't know how to go back and forth. All right. Let's see if we could reclaim the I'm going to stop share and I'll see if I could make this make host. Okay. All right. I think we are in business now. So let me go ahead and stop my video here first and let me share my screen now with you. Share screen, the whole screen. All right, I think we are good. And now I'm going to go to my working model. Here we go. All right, guys. So see what I did actually here. I created these blocks here. Block A, look, the mass of it is 10 kilograms here. And block E, the mass is 30 kilograms, right? And what I did is I have 3 cables here. Look, this is the configuration for that connection to pulley D. This is my second cable. So this is T1. This is T2. This is T3. And look, the mass of D, I made it almost zero. Mass of C, almost zero here, right? And mass of E, remember, was 30 kilograms. And what I did, because there are some movement, so if I go ahead and run this for you, right? Look, that's how this is gonna run. And look at the values that I got. Acceleration of A is minus 5.85, pretty much what I got. Acceleration of E was 0.73. And look at the tension. Tension 139 here, tension 279, and tension 3, 158. All right, guys. So just wanted to thank you. If you like this video, please do so and like it. And I would be very happy if you subscribe to my channel as well. So I'll see you guys soon, and take care.